actually this is the exercise number 9, right? And before going to discuss about the distance vector routing algorithm, the mechanism is like that. So here we need to get the number of edges. So here we are having, right, first we wanted to get the number of vertices. There are 4 vertices, 1, 2, 3, 4, and the edges is 5. 1, 2, 3, 4, 5. 5 edges are there, right? So for this matrices, we are going to find out the shortest distance, right? For example, if suppose I wanted to find out the shortest path between 1 to 4, right? So either I can go by using this route 1 to 2, 2 to 4. The total cost is 11. Or other way, I can go for 1 to 2, 2 to 3, 3 to 4. Right? 1 plus 1, 2. Right? 2 plus 4, 6. Then is there any other path? Yes. 1, 3, 4. The cost is 4 plus 3, 7. So in this 3 different route, the minimum cost is 4 plus 5, 5 plus 1, 6. That is 1 to 2, 2 to 3, 3 to 4. Right? This is the minimum cost to reach from source 1 to destination 4. So like that we are going to find out alternate route and we are going to find out what is the cost. For example, if suppose I wanted to reach source is 1, destination is 3. Right? The cost is 1 to 3 directly 3, or I can go for 1 to 2, 2 to 3. Right? It is 2. So the best route is 1 to going to 1 to 2, 2 to 3. So this is the way in which you can find out the shortest distance. Right now, what are the steps we wanted to execute? Right? What is the meaning of steps? The algorithm. So what we are going to do? Add the hop. Hop is nothing but the edges are called as a hop. So will be first step. We are adding all the source and destination. We are going to repeat the process until any one of the condition has to be true. That is, all the nodes are included. So if the destination is not in the routing table, that means if we are adding a new routing table, that has to be appended. So else if the destination is still not in the routing table, if suppose we are doing some modification in the entry, then also we wanted to include. Right? If hop count is smaller than 1 in the routing table, right? So in that case also the destination will not be added. Right? It should be incremental order. Right? The number of nodes should be, for example, 1, 2, 3, 4. Like that only we can add. So after adding 4, I cannot include 1. So that is the concept of last one. So the advertised hop count, right, smaller than 1 in the table. Then next one is take the next router routing table and its neighbor routing table. For each and every node, right, vertices, we will be having a routing table. We will be calculating a distance. So how we can calculate the distance? First we are taking a first node, right, in the entry table, and we'll be finding out how much cost is required, for minimum cost is required to reach the destination node. Like that we are going to identify what is the source and what is the destination. Is there any intermediate is there and how much of cost. So this is the fourth step. We are going to find out the source, destination, intermediate node and cost. Then based on that we wanted to update the source router routing table cost value. Right? For example, I told we wanted to go from 1 to 4. There are different routes. That value has to be updated and it has to be filled in the routing table. So here source as well as destination routing table has to be built. These steps has to be repeated for the number of nodes available or the number of vertices which is available in the right matrices. And after that, if suppose after updating all the information, suddenly I wanted to change the cost of any node, that can be right updated, and once again I wanted to do this process above steps again for completing or updating the routing table. So here what I am doing, right, see this number of vertices I am getting, number of edges I am getting, and then I already told reaching from 0 to 0 is 0. For example, here I am checking I equal to j. So root right, vertices 0, right, is the source, and vertices 0 itself destination. Then cost is also obviously 0. Otherwise, if the condition I and j is different value, then maximum I can, because I am going to get as a input, so that I do not know the cost, so that I am initializing as a maximum value. Then I am going to identify the edges one by one. What is the source, destination and cost. Like that for all the edges I am getting. and then I am going to build the routing table. So for that I will be finding out the distance and I will be filling that routing table. And here it is the initial routing table I am going to print. So after that I told, if suppose after printing the initial routing table I am changing some values. Here you can see for source 2 to 4, for example, I will be giving a input source is 2 and destination is 4 and I am updating the new cast is instead of 1 I am going to update 10. Right, then after that whether this has been updated and a new value is updated or not in the routing table has to be verified by seeing that new routing table. So this is the thing we are going to discuss in our program. Now we will see how it can be done. I'm going to take the online Java compiler. So where wait a minute, I'm going to execute this program once again. So I'm going to execute the same program I have copied here and I am executing. Wait a minute, it is executing. Now it is asking number of vertices. Program I am copying here. Right now I am going to make it as interactive mode because I am giving an input, so that I am executing this program. It is asking the number of vertices. It will ask you number of edges. Then it will ask you to fill the source, destination. It will ask you. So destination is 2. What is the cast? It will ask you the cast. Based on the diagram we have seen now. For that only I am going to create. So now first edge is 4. So totally 5 edge value we wanted to give. The second edge, the source is 1. The destination is 3. And cast is 3. Then it will ask you third edge. Third edge, the source is 2. Destination is 3. Cast will be 1. Then it will ask you fourth edge. Fourth edge is source is 2, destination is 4 and the cast will be 1. The cast will be 1. Then it will ask you fifth edge. So fifth edge, the source is 3, destination is 4, then the cast is 4. Now, I have given all the input, number of vertices, number of edges, and which one is the source, which one is the destination, and what is the cast. For all 5 edges I have given. Now it will build the routing table. You can see that this is the initial routing table. You can see that moving all diagonal elements are 0. What is the meaning of that? So I and j is I equal to j. We have verified now. So if I and j value is same, moving from source and destination is same, the cast is also obviously same. That is the thing it has been mentioned. Right? For first node to the second node, the cast is 1. Right? 1 to 2, the cast is 1. So 1 to 3, right? The cast is 2. Minimum we wanted to find out. And 1 to 4, right? The cast is 2. Right? Like that for each and every one we have identified. Now, if suppose after updating the routing table, if suppose I am changing the cast, I wanted to change the cast of a particular route. For that I am taking, I am telling that source node is 2. It will ask you the destination node. Wait a minute. So here I have given a destination value and I have changed the cast. Instead of 1 I have given 10. So now you can see that routing table value which is printed. Right, the new routing table. You can see that the updated routing table value will be printed here. Right. So here you can see that it will be a different value. 2 to 4 I have changed 10. So that the distance instead of 4 it will be 8. Is it not? Because I have modified here. So here you can see that from again reverse. Right, it is 2 to 4. Now it is 4 to 2. That is 8. Is it not? So in this way the routing table will be updated. So if you want to change any cast value after building a routing table, based on that the updation has to be taken place. So this is the example for the distance vector